Hello students. Okay, so I'm going to go over the 2020 exam sample questions that College Board released for our test. And on this document, it gives some instructions and just review about how you should submit your question or your work onto College Board, how you should write your work, and some other important details that I think it's very important for you to read on your own, okay, which was attached to this document. Okay, I'm going to focus when I'm doing this, making sure that I label all of my answers to the question, making sure I use my parentheses correctly, and leaving my numeric answers in unsimplified form, okay? And hopefully by now you've already practiced submitting your responses to up on College Board, okay? Now, here I have a sample question number 1, which is this, which has parts A, B, C, D, turn the page, E, F, G. And you have 25 minutes and 5 minutes to submit your work, okay? Now on question number 2, that one is 15 minutes plus 5 minutes to submit your work. Now, since it's 15 minutes, which is what we usually use for the standard FRQs that we've been practicing on, they said they encouraged us to practice FRQ number 4 and 5 from the 2019 exam. And they also said to review FRQ number 1. So it looks like question number 2 is going to be very similar to past FRQ type problems, okay? So I will be making a video for number 4 and 5 of 2019, okay? All right. So now let's get started with question number 1. All right. So on my paper, before you even start taking your test, you should write on your paper Apple AP ID number, your initials, and your page number that you are working on. You need the page number because sometimes this takes multiple pages, which I think number 1 will take at least 2 pages on mine. All right, so let's see. The continuous function f is defined on the closed interval of this. Okay, the figure above shows a portion of the graph of f consisting of 2 line segments and a quarter circle centered at this point. Okay, now it says a portion of the graph. So it says that f extends from -6 to 5, and it looks like I only have -2 to 5. So I am going to, just for myself, remind myself that this is the portion from -2 to 5, okay? 2 line segments and a quarter circle, which I have, see? Centered at right there. And it is known that the point, this point, okay, this is an X and this is a Y, is on the graph of this. So let me locate that. Okay, so that's given. Okay. All right, so here we go. If -6 to 5 of f of x dx equals 7, find the value of this. Show the work that leads to your answer. All right, looks like we're doing a properties of integrals type of problem. And I'm going to see part A. Let's see, I have -6 to 5 of f of x dx, and I know that's equal to 7, but what is -6 to 5 equal to? That is the area between the curve between the curve and the x-axis of f of x, okay, from the interval of -6 to 5. So here's my graph, -6 to 5, and they're curious about -6 to 2. So they're curious about this area, which I don't know anything about. So this is -6 to 2. Oh, sorry, -2. Plus the integral of -2 to 5 of f of x dx. Okay, so That's what this integral is equal to do these two integrals. And this is the one that is not shown, okay? And this is the area that is shown. All right, so now I have my equation set up using my properties of integrals. So now let's see how I can start working this out. -6 to, I keep writing 2, f of x dx plus, I can figure this out. So let's figure that out. -2 to 5. So that's all of this area, all right, between the curve and the x-axis. So the first thing I'm going to notice, at least I notice, is that, well, that, oh, you can't see that. That area and this area are equivalent, at least the absolute values are equivalent, but they will cancel each other out because one is positive, one is negative. And I can see that's the same for this one here and this one here. So, since I'm summing all of this up together, excuse me, I need to put these all back. All right. I can see that from -2 to 1, the area is going to be 0 because these two cancel each other out, these two cancel each other out. So I only need to worry about then actually calculating this area, which is a trapezoid, or you can do a square and a rectangle, whatever you like. And this area, which is not a quarter circle, on the outside of a quarter circle, right? Okay, so this is going to be 0. This is 0. Plus, now I'm going to work on this trapezoid. It's going to be 1/2. The first base is 1, and then the next base is 1, 2, 12, 3, and the height of that trapezoid is 1. Plus this area, which I'm actually going to have to do some sort of subtraction because I'm going to take the area of this square and I'm going to subtract that quarter circle. So it's going to be 9 is the area of the square minus the quarter circle. So the radius is equal to 3. So it's going to be pi r squared, so 9 pi divided by 4 because it's a quarter circle. Okay, and this is where they talked about parentheses being important. You want to make sure that you have your parentheses in the proper spots, okay? And we're solving for this guy right here. So you do not need to simplify this, but I'm just going to because I'm going to need to subtract all that stuff over. So I'm going to say 7 is equal to -6 to -2 of f of x dx plus, this is 4. 4 divided by 2 is 2. 2 plus 9 minus 9 pi over 4. Yeah. You could simplify that further, but yeah. Okay, so I'm going to be moving this over. So I'm going to say 7 minus 2 minus 9 plus 9 pi over 4 is equal to the integral of -6 to -2 of f of x dx. Okay, and again, you could simplify that. You're allowed to have your calculator available to you, so if you want to, you can put this into the calculator. It's up to you. Okay, but I'm just going to leave it like this. That's my answer. And is that what they, yes. And I will check my question again just to double check I'm answering the question. All right, part B. Says evaluate 3 to 5 of this expression. Okay, let me copy that down. 3 to 5 of 2 f prime of x plus 4 dx. Okay, they said to evaluate that. All right, so let's see. Well, this is another situation of properties of integrals. So I'm going to go ahead and separate this. So I'm going to go 2, 3 to 5 of f prime of x dx plus the integral of 3 to 5 of 4 dx. Okay? So now I'm going to use some FTC. FTC 1 and 2 is going to be applied here. Okay? First off, if I have the derivative, then it's going to be the antiderivative, which is just going to be f. And I'm going to go baby steps because I want to make sure that we follow completely. And that's going to be integrated from 3 to 5. Plus, properties of integrals. This is a horizontal line with the length of the base. The height is 4. The length of the base is going to be 2. Or you can go 4x and then from 3 to 5. Either way, you're going to get 4 times 2 if you remember that property. Okay? And so this is equal to 2. And so now I'm going to have f of 5 minus f of 3. That's my FTC. Okay, evaluating the definite integral plus 8. Okay, or you could leave it like that. Now, you're not allowed to leave your answer like this. They want to see that you can evaluate this. Once all the expressions are substituted in, then you can leave your answers unsimplified. So f of 5, I'm going to go to my graph. F of 5 is 0 minus f of 3 is, that deal. And so this is where parentheses matter, because if you don't put your parentheses, then you're not going to distribute that in, plus 8. And you can leave your answer like this. This is completely fine, and I'm going to do that because I don't want to mess up my simplifications and then lose my points, okay? All right, so now, Part C. Part C, it says the function g is given by this. Okay, so I'm going to write it down. -2 to x of f of t dt. Find the absolute max. Okay, I'm finding absolute max. Important. Value of g on the interval of this. Okay. Justify your answer. Okay, so absolute max, closed interval means closed interval method. And then I'm going to be using some FTC over here. All right, so closed interval method. Well, closed interval method, the first thing we want to do is we want to find the critical numbers. So let's see, the critical numbers of g of x. And you don't have to write this down. I'm just doing this for the video so we can follow along. Okay, is when g prime of x is equal to 0. So in g prime of x, since g of x is equal to this, then that means g prime of x is equal to our f of x by FTC. So basically, I'm looking for when f of x is equal to 0. Okay, so again, you don't need to write that out, but you can just write that, okay, so the critical numbers would be when f of x equals 0, and so when is f of x equal to 0? At, you won't do the endpoints there. At -1, at x equal to -1, and this is a slope of 2, so this must be 1/2, and x equal to 1/2. Okay, so here's this critical number and this critical number at 1/2. So you can narrow this down a little bit, because if you look, when x is equal to -1, your g prime changes from positive to negative, which means here you have a relative max. And here it changes from negative to positive, which means you have a relative min. Okay? Now, since we're trying to find an absolute max, a relative min is not a good candidate for an absolute maximum. A relative max is a good candidate. So we're just going to evaluate this. So now I found my critical numbers. Now what we want to do is compare the values at the critical numbers and the endpoints. So I'm going to do this, x and my g of x. And what are my endpoints? -2, and I have a critical number of -1, and I have an endpoint of 5. Okay, So g of negative 2 is equal to, you replace your x with 2, so negative 2 of f of t dt, well, negative 2 to negative 2, well, that is 0, okay? And g of negative 1 is equal to negative 2 to negative 1 of f of t dt. And so we're going to find the area under the curve, or between the curve and the x-axis, from negative 2 to negative 1. So negative 2 to negative 1, well, that area is 1/2. Okay, and then g of 5 is equal to negative 2 to 5 of f of t dt is equal to, so negative 2 to 5, which is everything I've already shaded. So it looks like I've done this work already. And it's, where is it? Aquí está. Negative 2 to 5. You don't have to re-show all of this. You can steal your answer, especially since I've already labeled this to be the area of that. So that means it's this guy right here. So I'm going to go 2 plus 9 minus 9 pi over 4. 2 plus 9, oh no, I forgot it. Minus 9 pi. Minus 9 pi over 4. All right. Okay, so now, well, I know that this is not going to be an absolute max because these are two positive. Well, at least I hope this is positive. Maybe I need to work this out, okay? If you know for sure that this is what this value is in relation to 1/2, then you can answer your question and just say that, oh, this is the absolute max, either this guy or this guy. If you're not too sure, remember you're allowed a graphing calculator. So I know that this is 11 minus 9 times 3-ish. What's 9 times 3? 27-ish. Okay, so it might be a little bit past that. So maybe it might be 30. Okay, I'll say 30-ish. That this is 30-ish divided by 4 is going to be 7-something-ish. Okay, so 11 minus 7-something-ish. What's 7-something-ish? Well, it will give me more than 1/2. So I can see that this would be the absolute max. Now, if you're not too sure, again, you're allowed your calculator. And here it is. 11 minus 9 pi divided by 4 is that, which is equal to 3.931. All right. Now, of course, you don't leave your answer like this. You want to tell them that you know that that's the absolute max. So then I would say, okay, where's the question? Okay. The absolute max of g of x on the interval of negative 2 to 5 is g of 5. And you can leave it as g of 5, or you can just write it as equal to 3.931. That's your conclusion. Okay? And then I have to use another sheet of paper. So APID number, initials, and page 2. Okay, and what problem? That was C. So now I'm on D. All right, D is this. Okay. It says limit as x goes to 1 of 10 to the x minus 3 f prime of x all over f of x minus arctangent x. Okay. Alrighty then. So now I need to evaluate this limit. So I might have to use L'Hopital's rule. I might not. Let's see. Well, first thing to do is to substitute 1 in. So let's substitute 1 in. So it's going to be 10 to the first power minus 3 times f prime of 1 divided by f of 1 minus arctangent of 1. All right. Well, I don't think I'm going to. Well, let's see what this is. Okay, 10 to the first is 10 minus 3 times f prime of 1. So I need to go to my graph over here. F prime of 1 This is the graph of f, so f prime is going to be its slope. So the slope is 2. F of 1, go back to this. What is the y value of 1? That is 1 minus our tangent 1. So this should be a flashcard. This is pi over 4. Okay? All right, I don't think I have a L'Hopital's rule here. It doesn't look like I'm getting any indeterminate forms. So let's see. Actually, you could just leave it like this. That's it. Everything is already substituted in for. Does it ask for anything else? No. I would leave my answer like this so you don't mess anything up, okay? I know this part is easy, but just leave it because you know me. All right, and so, and is that, there's no E. Okay, that's the end of that. Now let's turn the page over to this part. There's our E. All right, which this looks like a different problem. It says a function has derivatives of all orders for real numbers x. Okay, so that means that when I take the derivative of f, I can take an infinite number of derivatives for this. Okay? A portion of the graph of f is shown above. Okay, so this is a portion, along with a line tangent to the graph of f at x equal to 0. So this is a tangent line. Selected derivatives of f at x equal to 0 are given in the table above. Okay. So second derivative, third derivative, fourth derivative. Okay. Write the third degree Taylor-Pauli for f about x equal to 0. That's a good question. Okay, so we're on E. All right, so first I'm going to write that this is going to be f of 0 plus f prime of 0 times x to the first power plus f double prime of 0 times x squared divided by 2 factorial, which is 2, plus f triple prime of 0 x cubed, and what? Third degree. So I'm done. Like so. Okay, there's my formula that I'm going to follow. Now I'm going to substitute things into my formula. Okay, so let's see what I've got. For f of 0, it doesn't have that on the table, but f of 0, they said that this is the graph of f. And so that would be f of 0, 3. So I have 3 plus f prime of 0. Well, they don't have the first derivative, but they did tell me that this is the tangent line. So the slope of the tangent is the first derivative. So that is a slope of negative 2. So this will be negative 2x. Plus f double prime of 0. F double prime of 0 is, 3. So it's going to be 3 all over 2 factorial, or 2, x squared. Okay? And then plus f triple prime is negative 23 over 2 all over 3. Well, I'm just going to times it by 3 factorial. X to the third. Oh, yeah. You can leave it like that. You don't have to simplify further, but I just feel like doing that in this situation. I just feel like I might have to use this later on, so let me have it somewhat. Okay, this is what minus 23 divided by 2 times 3 factorial. I'm going to leave that like that for. Okay. All right. And there I have it. That is the third degree Taylor-Pauli about x equal to 0. Okay, so now f. Let h be the function defined by this. Of course. 0 x f of t dt. Use the Taylor-Pauli found in part E to find approximation for h of 1. Okay. Approximation for h of 1. Now, the reason why it's an approximation is because we're using the third degree. We're not using the entire series. The entire series is equal, the integral, I should say, of the entire series would be equal to h of x. So I'm going to do this. H of 1 is equal to the integral from 0 to 1 of f of t dt, which is approximately equal to, and I'm going to do the integral of this. Integral of 0 to 1 of, not the entire series, but the third degree polynomial. Okay. 3 minus 2x, I'm just copying this here, plus 3 over 2x squared. I'm leaving this like this. And don't forget your parentheses. That would be very bad if you leave out your parentheses right there, okay? All right, so then that means h of 1 is approximately equal to, well, let's integrate this. So this is going to be 3x minus x squared plus x cubed over 2, okay, because I'm just doing the power rule, minus 23 x to the fourth, and then over 4, so that's going to be another, so that's going to be adding on another 4 there, so I'll make it 4 factorial. From 0 to 1, okay? So h of 1 is approximately, okay, when I put 1 in, it's going to be 3 minus 1 plus 1/2 minus 23 over 2 times 4 factorial minus 0. Because when I put 0 in for all those x's, that whole expression is going to go to 0. You can leave it like that. If you want to simplify this, go ahead. But I'm just leaving it like this. You cannot leave it like this. Okay? You can leave it like this, and that's it. All right, now for g. G. One to infinity of 1 over x to the p plus 1 dx, where p is greater than 0. All right. So so we need to integrate this. So we're doing improper integrals. Okay, so I'm going to do limit as t goes to infinity of the integral from 1 to t of 1 over x to the p plus 1. Actually, you know what? X to the negative p plus 1. Like so. Dx. Okay. So what is that equal to? I don't know. Let me see. Limit as t goes to infinity of, okay, now I need to find the antiderivative. Okay. So let me distribute that negative. So this is going to be x to the negative p minus 1. Oh, yeah. So then if I add 1 to this, when I increase by 1, then this is going to be x to the negative p, because plus 1 and that minus 1 are going to cancel out. Divided by negative p. Negative p. Okay, yeah, negative p. Yeah. From, oh wait, yeah, from 1 to t, like so. Sure hope I did that correctly. All right, and then, okay. So then I need to put this in. And I'm running out of room. APID, initials, page number 3. And limit as t goes to infinity of x negative p over negative p from 1 to t. Alright, so this is going to be limit as t goes to infinity, and we're going to put t in for x. So I'm going to have t to the negative p divided by negative p minus 1 to the negative p all over negative p. And I feel like simplifying this a little bit, just because I feel like it. And so this is going to be t to the negative p all over negative p plus 1 over p. Yeah. So I want to factor a 1 over p out. It's going to be 1 over p limit. Should I factor out a negative? Let's factor out a negative. Okay. And so when I do that, this is going to be 1. Oh, t goes to infinity. And this is going to be 1 over t to the p plus, so not that, minus 1. And so then when I put this into, when I put infinity to here, I'm going to get, and that's going to be greater than 0. So this is going to be, if it's a positive root or a positive power, infinity to any of that is going to go to 0. So then I'm going to have negative 1 over p times 0 minus 1, which is going to be positive 1 over p. And that's it. I could have done that probably a little bit faster, but I struggle with these simple stuff. Okay, and that's it. Is that the end of my problems? Yes, I believe so. Yay! We finished, and it took me 3 pages. All right, and so next I will provide videos for FRQs 4 and 5 for 2019. Thank you.